Hello guys, welcome to this course on Introduction to Threads in Java. Now what are the objective of this course? The first objective is to give you the overview of threads in Java, and this video is all about that. In the next video we will see how to create our first application which uses threads. And we will get familiar with the Java thread syntax and API. And when we have the knowledge of how to create threads in Java, we will move to little advanced topics in Java threads like multithreading, synchronization, or thread pools, and some of the advanced topics. Now, first of all, we need to know the difference between multitasking and multithreading. Now, what is multitasking? Multitasking refers to the computer's ability to perform multiple jobs concurrently. And one of the examples you can say is your Unix system or your operating system itself. So, for example, your computer can run different processes, like you open Google Chrome, you open PDF viewer, or you open some presentation, you want to see a video in some media player. So these are all different processes, and the ability of your computer to handle these different processes or different tasks is called multitasking, right? Now, on the other hand, a thread is a single sequence of execution within a program. And we will see what this means in the later slides, but I will give you an example of thread. For example, your computer is running some browser, for example Google Chrome, and this is considered to be a process. So Google Chrome is a program, right? Now whenever you want to open multiple tabs, these tabs are working in parallel, right? And to achieve that, you can say these tabs are working on the threads, right? So a thread is a single sequence of execution in a program. So you can say different tabs in your browser are different threads, and your browser itself is a program. So multithreading refers to multiple threads of control within a single program, for example multiple tabs. And each program can run multiple threads of control within it, as I have given you an example of this browser. Now, what is the difference between concurrency and parallelism? Now consider you have one CPU in your computer and you want to run two processes. Now, how your CPU manages this is using concurrency. So your CPU allocates the priority to the processes, and whichever process have the more priority at the given time of interval, it is executed first. So whenever your CPU have some time to execute the second program, and it has the priority, it runs the second, then the first, then the second. So it utilizes the full capacity of your CPU. Now, in the other case, for example, you have two CPUs and you want to run two processes. You can run one process on a single CPU, right? So process 1 on CPU 1 and process 2 on CPU 2, and these processes are independent of each other. So this, in this case, we can say this is parallelism and this is concurrency, right? Now, there are two terms. One is process and one is thread. And what is the difference between threads and processes? Once again, I give you the example of the CPU. So you have single CPU. And as I have given you an example in earlier slides, your CPU can run different processes. For example, process 1 is your PDF viewer, some kind of PDF viewer. Process 2 is your media player. Process 3 is your browser, for example, Google Chrome. Process 4 is some kind of presentation is running on it, right? So these are different processes running on it. So what is a process? An executing instance of a program is called process. So process 1, process 2, process 3, and process 4. So these are the executing instances of a program. Now a thread is a subset of a process. So for example, we take the process 3, which is running Google Chrome. And this process can run different threads. For example, different tabs are running on the basis of different threads, right? So a single process, for example, Google Chrome, is running different tabs, for example, different threads, right? So a thread is a subset of a process. Now, threads shares the address space of the process that created it. So processes have its own address space. So this process have its own address space, this process have its own address space, and other processes also have their own address space. But multiple threads shares the address space of a process. So different threads in this process will share the address space of this process, right? So this is the difference between processes and threads. Now, where are threads good for? So there are different situations in which threads are good. So first of all, to maintain the responsiveness of the application during a long running task. So for example, you write a program which collects some data from some device, and you want to give this data on the basis of a request from client, for example, right? So you want to collect the data in parallel with the catering of the client's request. So in this situation, you can use threads, right? Second is to enable the cancellation of separable tasks. For example, you are collecting data with two devices and you no longer want the data from one device, so you want to cancel this task, right? But you don't want to cancel the task which is collecting the data from the first device, right? So you can cancel this thread using some piece of program or code, right? Now the next is some problems are inherently parallel, so you cannot do anything about this. For example, I have given you the example of tabs, right? You want to run two tabs or two videos in two different tabs of your browser, and both are running in parallel. So how will your browser handle this? It can create a thread for that, right? Next is to monitor the status of some resource, for example, your database, or some APIs and system demands it, like your Swing applications in Java demands it, right? So these are the situation in which you can use threads. Now, what is an application thread? So as we all know that whenever a Java program is created, it's run on the JVM, which is Java Virtual Machine, right? So whenever we execute a Java application, the JVM, which is Java Virtual Machine, creates a thread object whose task is to define a main method, and it starts the thread. As we all know, every Java program has at least one main program and only one main program. So whenever you create or whenever you execute this program, your JVM creates the threads whose task is to define this main method, right? Now the thread executes the statements of the program one by one until the method returns or this thread dies, right? Now in the last, how we can create multiple threads in our program. So each thread has its private runtime stack, and if two threads executes the same method, each will have its own copy of local variable the method uses. However, all threads see the same dynamic memory. Okay? So two different threads can act on a same object and the same static field concurrently. Now, how we can create the threads in Java? This we will see in the next video, programmatically how we can create the Java threads by writing some program, right? But basically, there are two ways to create our own thread object. One is subclassing from the thread class. So there is a thread class in Java, and then instantiating the new object of this class. Okay, so subclassing from a class called thread, and we will instantiate a new object of this class, and then we can create the thread. Or otherwise, there is an interface called runnable. So implementing this runnable interface will create a thread also. But in both cases, we need to call this method called run, which should be implemented, right? So this run should be implemented in both cases. And this is what we are going to see in the next video, how we can create our first program using threads. So that's it for this video. I hope you will see the next video also. So please rate, comment and subscribe, and bye for now.